Welcome to sureshbhattclasses. We are solving question on quantitative aptitude topic numbers. All the topics of quantitative aptitude are useful for many competitive exams like SSC, CGL, RRB, Bank PO, Railways, and many government job exams and job interviews. These topics are also useful for many entrance exams like GRE, SAT, ACT, CAT, GMAT, and many more. Please watch all my videos on quantitative aptitude topics. In this video, we are solving questions on number of factors. Our question is, find number of factors of 2 to the power 6 multiplied by 5 to the power 5 multiplied by 7 to the power 3 which are divisible by 10. The given options are option A 100, option B 90, option C 120, option D 125. Before solving this question, I request you to please subscribe to this channel. We have to take common 10 out of given number for finding the number of factors which are divisible by 10. And 10 is nothing else but 2 multiplied by 5. We have taken out 2 multiplied by 5 from 2 to the power 6 multiplied by 5 to the power 5 multiplied by 7 to the power 3. After taking 1 2 out of 2 to the power 6, the remaining power of 2 is 2 to the power 5 multiplied by, after taking 1 5 from 5 to the power 5, the remaining power of 5 is 4. So it is 5 to the power 4 multiplied by 7 to the power 3. Now we will find the number of factors of 2 to the power 5 multiplied by 5 to the power 4 multiplied by 7 to the power 3. The power of 2 is 5. So we write it as 5 plus 1. We add 1 to each power. So we have written 5 plus 1, which is power of 2. Now 5 has power 4. So we write 4 plus 1. And 7 has power 3. So we write 3 plus 1. So this is 5 plus 1 multiplied by 4 plus 1 multiplied by 3 plus 1. And this is equal to 6. 5 plus 1 is 6. 4 plus 1 is 5. And 3 plus 1 is 4. So this is 6 multiplied by 5 multiplied by 4. And 6 times 5 is 30. And 30 times 4 is 120. So this is equal to 120. It means that there are 120 factors of given number which are divisible by 10. And from the given options, our answer is option C, 120. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, if n has 12 factors, then how many factors of n square are possible? The given options are option A 33, 35, 45. Option B 25, 27, 30. Option C 30, 33, 36. Option D 40, 45, 49. Before solving this question, I request you to please subscribe to this channel. The factors of 12 can be written as 4 multiplied by 3 or 2 multiplied by 2 multiplied by 3 or 2 multiplied by 6. Then n can be a to the power 3 multiplied by b to the power 2, where a and b are prime factors of n with the power 3 and 2, because if a has power 3, then 3 plus 1 is 4 and b has power 2 So 2 plus 1 will be 3, and with that 4 multiplied by 3 will be 12. Or it can be a to the power 1 multiplied by b to the power 1 multiplied by c to the power 2. And if these are the powers, then the factors will be a to the power 1 is 1 plus 1 will be 2, b to the power 1, then 1 plus 1 will be 2, and c to the power 2 will be 2 plus 1 is 3. Or n can be a to the power 1 multiplied by b to the power 5. Then the factors can be 1 plus 1 is 2 and 5 plus 1 is 6. This way we can have the values of n. Then n square equal to, what will be n square? We have to square all these quantities. So n square can be a to the power 6 multiplied by b to the power 4, or a to the power 2 multiplied by b to the power 2 multiplied by c to the power 4, or a to the power 2 multiplied by b to the power 10, as 5 times 2 is 10. Now if these are the values of n square, then number of factors will be, the power of a is 6, so we add 1 to it, so it will be 6 plus 1 is 7, multiplied by power of b is 4, so it will be 4 plus 1 equal to 5. Or a to the power 2 is there, so it will be 2 plus 1 is 3, multiplied by power of b is 2, so it will be again 2 plus 1 is 3, and power of c is 4, so it will be 4 plus 1 is 5. Or the power of a is 2, so it will be 2 plus 1 is 3, multiplied by power of b is 10, so it will be 10 plus 1 is 11. And these are 7 times 5 is 35, or 3 multiplied by 3 is 9, 9 times 5 is 45, or 3 times 11 is 33. So we write all these number in ascending order. So that will be 33, 35, 45. So these are the possible values of factors of n square. And from the given options, our answer is option A, 33, 35, 45. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the total number of factors of 5 to the power 7 plus 5 to the power 8 plus 5 to the power 9 plus 5 to the power 10 plus 5 to the power 11. The given options are option A 45, option B 42, option C 36, option D 32. Before solving this question, I request you to please subscribe to this channel. We take common 5 to the power 7 from the given question, then it will be 5 to the power 7 multiplied by 1. In place of 5 to the power 7 it will be 1, plus 5 to the power 1. In place of 5 to the power 8 it will be 5 to the power 1, plus 5 to the power 9 will be 5 to the power 2, as we have taken 7 power out of it, plus in place of 5 to the power 10 it will be 5 to the power 3, plus in place of 5 to the power 11 it will be 5 to the power 4. And this is equal to 5 to the power 7 multiplied by 1 plus 5 plus 5 to the power 2 is 25, plus 5 to the power 3 is 125, plus 5 to the power 4 is 625. And this is equal to 5 to the power 7. So we add all these numbers. 625 plus 125 is 750, plus 25 is 775, plus 5 is 780, plus 1 is 781. and this is equal to 5 to the power 7 multiplied by 11 multiplied by 71. If we observe this number 781, then this number is divisible by 11, and on dividing 781 we get 71, and 11 and 71 both are prime numbers, so this cannot be further factorized. Now we can write it as 5 to the power 7 multiplied by 11 to the power 1 multiplied by 71 to the power 1. Now number of factors will be, we have to add 1 to each power of prime factors, and the power of 5 is 7. So we write 7 plus 1 multiplied by power of 11 is 1. So we write 1 plus 1, and power of 71 is 1. So it is again 1 plus 1. And this is equal to 7 plus 1 is 8 multiplied by 1 plus 1 is 2 multiplied by 1 plus 1 is 2. So this is 8 times 2 is 16, and 16 times 2 is 32. So the total number of factors of given questions are 32. And from the given options, our answer is option D, 32. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the total number of factors of 2 to the power 12 plus 2 to the power 12 multiplied by 3 to the power 12 plus 3 to the power 12 plus 3 to the power 12 multiplied by 4 to the power 12 plus 4 to the power 12 plus 4 to the power 12 plus 4 to the power 12. The given options are option A 560, option B 460, option C 520, option D 380. Before solving this question, I request you to please subscribe to this channel. The given number has 2 to the power 12 for 2 times, multiplied by 3 to the power 12 for 3 times, multiplied by 4 to the power 12 for 4 times. So the number can be written as 2 multiplied by 2 to the power 12 in one bracket into in another bracket 3 multiplied by 3 to the power 12 multiplied by in third bracket 4 multiplied by 4 to the power 12. So this is equal to 2 multiplied by 2 to the power 12 can be written as 2 to the power 13 multiplied by 3 multiplied by 3 to the power 12 can be written as 3 to the power 13 multiplied by 4 multiplied by 4 to the power 12 can be written as 4 to the power 13. So this can be written as 2 to the power 13 multiplied by 3 to the power 13 multiplied by 4 to the power 13 can be written as 2 to the power 26, as 4 is 2 to the power 2 and 4 to the power 13, the power of 2 to the power 2 and 13 is multiplied, so it becomes 2 to the power 26. This is equal to 2 to the power 13 multiplied by 2 to the power 26. We have to add the power, so it becomes 2 to the power 39 multiplied by 3 to the power 13. Now we have 2 to the power 39 multiplied by 3 to the power 13, and we know that for finding the number of factors we have to add 1 to the power of each prime factor. So number of factors will be 39 plus 1, as the power of 2 is 39, and 13 plus 1 as power of 3 is 13. So this is equal to 40 multiplied by 14. 39 plus 1 is 40 and 13 plus 1 is 14. And 40 multiplied by 14 is 560. So there will be 560 factors of given question. And from the given options, our answer is option A, 560. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the factors of 47 to the power 3 minus 24 to the power 3 minus 23 to the power 3. The given options are option A, 3 and 47, option B, 47 and 24, option C, 24 and 23, option D, 3, 47, 24 and 23. Before solving this question, I request you to please subscribe to this channel. We know the identity a cube plus b cube plus c cube equal to 3abc if a plus b plus c equal to 0. Here 47 is a plus minus 24 is b plus minus 23 is c, and this all equal to 0 as 47 minus 24 minus 23 equal to 0. So the factors will be 3, a, b, c. So the factor of given questions are 3 multiplied by 47 multiplied by 24 multiplied by 23. Therefore, from the given options, our answer is option D, 3, 47, 24 and 23. These are the factors of 47 to the power 3 minus 24 to the power 3 minus 23 to the power 3. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find total number of factors of 79 to the power 3 minus 46 to the power 3 minus 33 to the power 3. The given options are option A 16, option B 24, option C 32, option D 48. Before solving this question, I request you to please subscribe to this channel. We know the identity a cube plus b cube plus c cube equal to 3abc if a plus b plus c equal to 0. Here a is 79 plus b is minus 46 plus c is minus 33, and this all equal to 0. Therefore, we can factorize 79 to the power 3 multiplied by 46 to the power 3 minus 33 to the power 3. This can be written as 3 multiplied by 79 multiplied by minus 46 multiplied by minus 33, and this is equal to 3 multiplied by 79 multiplied by 46 multiplied by 33. Now we further factorize these numbers into prime factors. This is equal to 3 is a prime number, 79 is a prime number, and 46 can be written as 2 multiplied by 23, where 2 and 23 both are prime numbers, and 33 can be written as 3 multiplied by 11. Here 3 and 11 both are prime numbers. Now we have factorized every number into prime factors. Now we write all these numbers into ascending orders. This is 2 to the power 1 multiplied by, there are 2 3's, so that will be 3 to the power 2 multiplied by 11 multiplied by 23 multiplied by 79. We know that the number of factors are product of power of prime factors plus 1. So here the number of factors will be 2 has the power 1, so we can write it as 1 plus 1. 3 has power 2, so we can write it as 2 plus 1. 11 has power 1, so it is again 1 plus 1. 23 has power 1, so it is 1 plus 1. And 79 has power 1, so it is 1 plus 1. This is equal to 2 multiplied by 3 multiplied by 2 multiplied by 2 multiplied by 2. This is equal to 2 times 3 is 6, 6 times 2 is 12, 12 times 2 is 24, and 24 times 2 is 48. So there are total 48 factors of given number. And from the given options, our answer is option D, 48 factors. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, when 250 is divided by positive integer x, the remainder is 10. What is the number of all possible values of x? The given options are option A 16, option B 18, option C 12, option D 20. Before solving this question, I request you to please subscribe to this channel. When 250 is divided by x, the remainder is 10. It means that 250 minus 10 is equal to 240 is divisible by x, and as the remainder is 10, it means that x is greater than 10. Now we will find the all factors of 240. The prime factors of 240 are 2 to the power 4 multiplied by 3 to the power 1 multiplied by 5 to the power 1. 2 to the power 4 is 16. 16 times 3 is 48, and 48 times 5 is 240. So the prime factors of 240 are 2 to the power 4 multiplied by 3 to the power 1 multiplied by 5 to the power 1. So the number of factors is, we have to add 1 to power of each prime factor and we have to multiply them. So the power of 2 is 4, so we write 4 plus 1. Power of 3 is 1, so we write 1 plus 1. And power of 5 is 1, so we write 1 plus 1. And this is equal to 5 multiplied by 2 multiplied by 2 is 20. 5 times 2 is 10, and 10 times 2 is 20. So there are total 20 factors of 240. Now, as x is greater than 10, so we have to take out all those factors which has the value less than 10 from 20. So those numbers are 1, 2, 3, 4, 5, 6 and 8 and 10. These are total 8 factors which has value less than or equal to 10. So the factor which has value more than 10 are 20 minus 8 equal to 12 factors. So there will be 12 factors which has value more than 10, and these are all 12 factors are the possible values of x. And from the given options, our answer is option C, 12. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, if n equal to 4 to the power 11 plus 4 to the power 12 plus 4 to the power 13 plus 4 to the power 14, then how many positive factors of n are there? The given options are option A 92, option B 48, option C 50, option D 51. This question or similar question was asked in CGL Mains 2017. Before solving this question, I request you to please subscribe to this channel. We have to take common 4 to the power 11 from the given number. So we write 4 to the power 11 into, within bracket, in place of 4 to the power 11 we write 1, plus in place of 4 to the power 12 we write 4, plus in place of 4 to the power 13 we write 4 to the power 2, as we have already taken common 4 to the power 11, plus in place of 4 to the power 14 we write 4 to the power 3. This is equal to 4 to the power 11 multiplied by, within bracket, 1 plus 4 plus 4 to the power 2 is 16, plus 4 to the power 3 is 64. This is equal to 4 to the power 11 multiplied by, we add all these numbers, 1 plus 4 is 5, plus 16 is 21, plus 64 is 85. So we write 85. Now we further factorize this number into prime factors. 4 to the power 11 can be written as 2 to the power 22 multiplied by 85 can be written as 5 multiplied by 17. This can be written as 5 to the power 1 multiplied by 17 to the power 1. And for finding the total number of factors, we know that we have to add 1 to powers of all prime factors and then multiply it. So this is equal to 22 plus 1, as the power of 2 is 22, multiplied by 1 plus 1, as the power of 5 is 1, multiplied by 1 plus 1, as the power of 17 is 1. This is equal to 22 plus 1 is 23, multiplied by 1 plus 1 is 2, multiplied by 1 plus 1 is 2. Now 23 multiplied by 2 is 46, and 46 times 2 is 92. So we write equal to 92. These are the total number of factors of given question, and from the given options our answer is option A, 92. I hope you have understood the method of solving such type of questions. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.